Okay, hi everybody. I just wanted to do a quick mini tutorial on A subgrouping. So if you could please just grab your ABO module and turn to page 14, we will get started. In your module, it talks about the differences between the A1 and A2 phenotype. The A2 phenotype is quantitatively different and qualitatively different than the A1 phenotype. And we talk a bit in the module about the quantitative differences, being that there's decreased number of antigen sites on A2 cells, decreased amount of the transferase enzyme. It's actually less efficient than in A1 phenotype. And this isn't talked about in your module, but there's a decreased amount of branching in the formed antigen in A2 phenotype. Qualitative differences, as it states in your module, must also exist because the formation of anti-A1 occurs in some A2 and A2B individuals. In addition, there's differences in the H change, and there actually is subtle differences in the transferase enzyme as well. So in the second paragraph on page 14, for clarity, could you please change it to read, the immunodominant sugar on both A1 and A2 red cells is N-acetylgalactosamine. Okay, so there's a handout on Brightspace that actually depicts these same or similar diagrams. The A1 phenotype is often depicted as a cell with a lot of A and A1 antigen on it, and the A2 phenotype is depicted as a cell with not so much A antigen on it. And this isn't in your module, and it's not hugely important to us, but the antigens on the A1 phenotypic cell are built on primarily branched H structures, but also on straight H structures, and the antigens on A2 phenotype are built predominantly on straight structures. Okay, so enough of that. Why do we care? Well, 1 to 8% of A2 individuals make an anti-A1, and 22 to 35% of A2B individuals make an anti-A1. And looking down here at what I've got on the bottom of the page, this is what they would look like if we did an ABO typing on someone who is possibly A2 with an anti-A1 and A2B with an anti-A1. So notice this A person is reacting 4+ with anti-A, not at all with anti-B, which is what we would expect of an A person. And then in their plasma is reacting 4+ with the B cells, as expected. But look at the reaction of their plasma with the A1 cells. We don't expect that. In the A2 or in the AB person, who we might think is an A2B making an anti-A1, we can see 4+ reactions in the forward grouping as we expect with an AB person. And in the reverse grouping, the patient's plasma is not reacting with B cells as would be expected, but we have a reaction with the A1 cells in the reverse grouping, which is not expected in an AB person. Okay, so I've just drawn those two situations back at the top of the page here. So notice the unexpected part is that there is a reaction of the patient's plasma with the A1 cells. Well, how do we resolve this? We do 3 things. So refer to your ABO module on page 15. First, we're going to test the cells of the patient, or if we're working with a donor, of the donor, with anti-A1 lectin. So do they react with the anti-A1 lectin? If they do, then those are A1 cells, and therefore the reaction of their plasma with the A1 cells in the reverse grouping is not due to anti-A1. When you test the cells with anti-A1 and they don't react, well, the cells are not A1 cells, and they are probably A2. And you guys did this in the ABO subgrouping lab. I think you did a really good job of it. The second thing we're going to need to do is to test the patient's plasma with A2 cells. Does the patient's plasma react with A2 cells? If it does, well, A2 cells do not have the A1 antigen on them, so perhaps the patient's plasma is reacting with some other antigen on these A2 cells, perhaps the M antigen or the P antigen. So, what if the patient's plasma does not react with the A2 cells? Well, this is more evidence then, isn't it, that the patient plasma contains anti-A1. The next thing we need to do is an antibody screen. So we're going to take the patient's plasma and react it with 3 screening cells. Remember that screening cells are group O. Do the screening cells react? If they do, then the patient has a non-ABO antibody in their plasma. The screening cells reacting does not explain an anti-A1. Remember that screening cells are group O. When you perform an antibody screen, if there is no reaction with the antibody screen in the patient's plasma, then the patient does not have a non-ABO antibody in their plasma. So, what evidence is required to say that a patient is probably A2 with the anti-A1? First off, when you do the ABO typing, you're going to see an unexpected reaction in the ABO typing, and that's your first clue. But it's only your first clue. Secondly, you will take your patient's cells and react them with anti-A1. They will not react. Third, you'll take your patient's plasma that you're concerned contains the anti-A1 and react it with A2 cells. It will not react. And lastly, you'll take the patient's plasma and run an antibody screen on it and ascertain that it does not contain other non-ABO antibodies.